All right, so for today, we're going to be looking at piecewise functions. We've been doing that for a couple of days now. So learning intention for today, we're going to be learning how to use graphs and stories together to understand the relationships between two quantities. The success criteria has been the same. However, I've just added on there how to graph piecewise functions. We're going to go through that a little bit, not too in depth. It's just so that we get a brief understanding of what how piecewise functions work and their equations, and then we're trying to find f of x values or x values, and then we'll go into some exercise. As I go through this and there are questions, put your questions in the chat and then I'll see them, all right? Because with this recording, we don't want the voiceover, so just put it in the chat and I'll see it real quick. Again, this recording is something that you're going to be able to go back and look at. It's going to be right here. I already have a video there, but it's going to be right here. And you could go back and watch it. So to start, let me get my text box. And we're defining a piecewise function. I advise you getting your paper and your pen. All right, you're going to need that, or a pencil. Piecewise function. And we're going to define a piecewise function as a function. Piecewise function is a function that is defined by at least two equations put together on one graph. They each have different domains. Could someone put in the chat what domains mean? We talked about this earlier on when we're talking about domain and range. Does anyone remember what that is? Go ahead and put it in the chat, please. And then we're going to give some examples. Some examples of piecewise graph is if we have a graph with this graph, we have two different lines and it makes a piecewise graph. There's another type of graph that's called a step function. And that is where we have, basically it's called a step function because it's a step. So this is a piecewise function. Again, at least two equations put together in one graph. With this, that was one equation, and then there's that one. And then even yesterday when we went through some stuff, we had a graph that I think it looks something like this. The guy that was spinning on the wheel, all right, at the park. So that's an example of, those are examples of what piecewise functions are, just different equations on a graph. And they have different domains. And when we talk about domains, we talk about the x values. All right? When we talk about domains, we talk about the x values. So this is the y, this is the x. Could someone tell me what the y values are called? The domain is considered the range of the x values in which the graph covers. All right, so we have y and we have the x-axis. My apologies for not labeling these. We always want to label our axes. So these are the domain values, and then you have the range values. All right, so they all have different domains. So with this graph, the domain for this graph is from here to here and here to here. So we see how these two equations have different domains. All right. To continue, we're going to look at this example. And bear with me as I draw this. This graph, I have my y-axis, my x. This is the origin, which is 0, which means everything on this side is positive, right? And everything on this side is negative because it's on the, this is the number line. I don't know if you realize that, but this is the number line, right? And then this goes down as well, and it continues. And we're going to label this 2. This is a 2. It's not negative. So this is to the right side of the 0. So it is positive. And below it would be negative. I'm going to draw a line. It goes like that. Wow, look at that line. Come through, Mr. McKnight, with the line. Right there, we've got those two equations combined together to make a piecewise function, two linear graphs put together. These are linear lines, all right? So with this piecewise function, we have two linear lines coming together to make a piecewise function, a piecewise graph. And then I'm gonna say f of x, which is also y, or the range, is equal to what x is and negative x. So f of x is equal to x and negative x, but it's equal to positive x when x is greater than or equal to 0. But it's equal to negative x when x is less than 0. Let me rewrite this. When x is less than 0. All right, so this whole piecewise function, and the reason why there are two separate functions, two separate equations, so x is an equation and negative x is also an equation, all right? It's like I'm telling you that f of x is equal to x and f of x is equal to negative x. But then I put two of them together, so this is x, this is negative x, and I put two of them together to make the piecewise function. I know that whenever x is greater than or equal to 0, so x greater than or equal to 0 is everything to the right, because this is the positive side. Anything that's x greater than or equal to 0, it's positive, right? That's the positive side of the number line. So I know that all these x values over here are positive. So then my y value is positive. That's what they're saying. So whenever I have a x value that's negative, if my x is less than 0, my x is less than 0, which is all these numbers on this side, then my x will be negative. And I know that. That's a number line. If it's less than 0, then this is -1, -2, -3, -4. So then I know it's negative. If it's equal to 0 or greater than 0, then all my numbers are positive. That's simply what that is saying. So with a piecewise function, you have two different equations coming together to form the piecewise function. And they have separate parts. So the definition said that they have different domains. This is what we're talking about. With this line, the domain is positive. That's why it's a positive x. With this line, the domain is negative. That's why it's a negative x. If you have any questions about that, just put it in the chat and I'll see it. Again, this is recorded, so you could always go back and watch it. All right, we're going to go through some exercises where it will help you to understand a little bit more. We're going to go through one more example, and then after we go through the one example, then we'll go through a little bit more like interactive exercise. The other thing that I want to do, we're going to go through another example. This time I'm not going to draw the graph, all right? But this piecewise function, this piecewise graph that I'm about to show you, f of x, which f of x is the range or the y values. F of x is equal to 0. F of x is equal to 0 when x is greater than or equal to -2, or it is less than 1. You see how I put that in there? So this right here is saying x is greater than or equal to -2, or x is less than 1. All I did was just put the two things together. All right? We're going to look at another one. F of x is equal to 3 when x is greater than or equal to 1 or less than 5. I'm just putting the expressions together. X is greater than or equal to 1 or X is less than 5. The next one, let's get a different color. F of X is equal to 5 when X is greater than or equal to 5 or less than 7. We know when there's that line underneath the greater than sign, it means that it's equal to it as well. All right, if there's none, then it's not equal to it. And we talked about this in 7th grade. If there's a line underneath it, then that's a solid dot. Do you remember that? And if there's none, then it's a circle. All right, and we'll talk about that later on. So the next part about this is we already defined what the function is. We have f of x can be 0, f of x can equal to 3, f of x can equal to 5. It just all depends on the range or the domain, all right? So the domain for this one is all the numbers between 1 and -2 inclusively. So in the chats, what I want us to do, we're gonna answer some questions. So what if I want to find the value for f of 2? If I want to find the value for f of 2, what would this answer be? What would, put it in the chat. If I want to find the value for f of 2, what would this answer be? If I want to find the value. So we're going to look up here and we're going to look which part of this would 2 as x, because we're finding what they told us that x is 2 and we're finding f of 2. So we're finding the y value for when x is 2. We're finding the f of x value when x is 2. So let's look up here. Would 2 be between 1 and -2? Would 2 be between 5 and 1? Or would 2 be between 7 and 5? 3, yep. So my answer for this one is 3. That's it. Keep in mind, this could be a graph. This could be a graph and we have the different lines drawn and then we'd look at it and see what the values are. But this time they didn't give us the graph, they gave us the expressions, the numbers, all right, the ranges and the domain. The next one that I want us to look at is if x is 0, what is f of 0? How do I find what is f of 0? Look into the range and see what f of 0 would be. F of 0, let's look. Yep, because 0 would fall in between this range, so then f of 0 is 0. Keep in mind, f of x is the same thing as range and the same thing as y, all right? So when I say f of 0 is 0, I'm saying when x is 0, y is also 0. With this one up here, when I say f of 2 is 3, I'm saying when x is 2, y is 3. So if, say, for instance, 2 was right here and 3 was right here, I could find this point. All I have to do is come to right here. That's what this point would be. It's saying when x is 2 on the x line, y is 3. This one is saying when x is 0, y is 0. So it would be here. The next one that I want us to look at is f of 1. What is f of 1? F of 1, what is f of 1? When x is 1, what's the y value? I'm getting 3, 3. When x is 1, yeah, y is 3. So let's put a 1 here, and it comes to about here. When x is 1, y is also 3. So then 3. Let's look at f of 6. I'm going to put couple on here. So don't just put the answer, put what. So if you're going to put the answer for f of 6, put f of 6 is equal to whatever. because I'm going to put several on here. And if we just put the answer, then we'll lose track. So f of 7. Let's find those. What are those? F of 6 is 5. The second one is f of -4. And then the last one is f of 7. Let me write this a little bit better. And then f of -4. So I'm going to plot f of 6. So f of 6 is about here, and this goes up to 5. Let's do that. This is where f of 7 is 5. Let's look at that. F of -4 is 0. Let's look at that. So let's look at f of -4. Which one of these would f of -4 be in between? Let's do 1, 2, or 3. So the first one is 1, second one is 2, second one is 3. Where would -4 be? Is -4 between 1 and -2? Yes. It's none. It's not on there. There's no f of -4 on there because -4 is not -4 is not between 1 and -2. So if I go on the number line, let's get the number line right here. This is -1. This is -2. This is -3. This is -4. So this right here is saying between 1 and -2, between these two. That's what that one is saying. But we're trying to find -4. Oh yes, -2 is greater than -4. Because remember, this is the number line. So for this answer, we put undefined. For that answer, we put undefined. And then now we're looking at f of 7. So with this one, it says 5 to 7. All right. However, the 5 has the dot because it has the x is greater than or equal to, but the 7 doesn't, so it's a circle. So we're between these 2 points, but there's no f of 7 because it's not equal to 7, it's less than 7. So this one is also undefined. I'm gonna let us write that down for a little bit, but this is basically just an introduction to piecewise functions. We did one where we weren't given the graph, or we're given the domain, and we're trying to figure out what the range is, the y values. But then we're also given one where we have a graph, and we're trying to manipulate and figure out the different parts of it. I will leave this up right here for a second so that we can write it down. With that said, see you next time.